If a business wants to double its output, the most intuitive path seems to be doubling the workforce. To test that assumption, we can look at a controlled scenario, a single acre of land. We keep the land size fixed and incrementally add one worker at a time to see how much wheat we can actually grow. Table 6.1 tracks the results. While the labor count in column 2 grows steadily, the total product, or TP, in column 3 does not scale at the same rate. After the fourth worker, each new hire brings less and less additional wheat to the total. This data reveals a ceiling on growth. Because the land itself is a fixed resource, a firm eventually reaches a point where hiring more people no longer increases scale. Mapping this data shows the physical limits of the farm. The TP curve climbs as we add labor, but it eventually levels off, reaching its maximum height here at point E. To understand why it levels off, we look at marginal product, the wheat produced by the next worker. In panel B, this curve shows that while early workers are highly productive, the value added by each subsequent hire declines towards zero. There is a specific tipping point where the marginal product line drops below the horizontal axis, entering negative territory. In this zone, workers are so overcrowded they actively get in each other's way, causing the farm's total output to drop with every new hire. Because hiring has a fixed physical limit, a firm that wants to keep growing must eventually invest in machinery and land, moving from the short run into the long run. In the long run, a firm has two variables it can change to increase production: labor, the human workforce, and capital, the machinery and equipment. A firm can produce the exact same amount of goods using different recipes of these two inputs, for example, using many workers with hand tools or fewer workers operating heavy machinery. We can map these recipes on a grid to create an isoquant. Every point along this curve, like B and C, represents a different combination of labor and capital that produces the same level of output. The curve bows inward because of the marginal rate of technical substitution. You cannot simply swap one machine for one person indefinitely. As you use less machinery, you need increasingly larger amounts of labor to maintain production. This curve represents the physical reality of what is possible to produce, but it does not account for the firm's financial limitations. Every firm operates under a total financial outlay, a strict budget for how much they can spend on production. This budget is anchored by the market price of a worker's wage and the price of a machine. We visualize this limit as an ISO cost line. It is a straight boundary showing every combination of labor and capital the firm can afford with its total budget. The steepness of this line is determined by the ratio of wages to machinery costs. If labor becomes more expensive relative to machines, the line becomes steeper. This sets up a puzzle. The firm must find the best physical recipe from the curved isoquant that fits within the rigid, straight line of their budget. To maximize efficiency, the producer must find the single point where their production capabilities align with their budget. When we overlay the budget line onto the production curves, we find a specific point of tangency at point M. This is the highest level of production the firm can reach without exceeding its budget. This producer equilibrium is the most efficient use of resources for that budget. Here, the curve's slope perfectly equals the budget line slope. The marginal product of the last dollar spent on labor equals the marginal product of the last dollar spent on capital. If a firm operates at any other point on the budget line, they are forced onto a lower isoquant, meaning they are getting less output for the same amount of money. These equations translate into a rule for how a firm survives in a changing market. True balance is reached when the final dollar spent on a worker yields the same output as the final dollar spent on a machine. If the price of labor or capital shifts, the slope of the budget line rotates, breaking the equilibrium. To return to the most efficient point of tangency, the firm must substitute the now cheaper resource for the more expensive one. Market balance is a geometric result of firms seeking the highest possible output within the constraints of their budget.